In this video we'll do number 1 and 2. So number 1, there is a termite infestation in Mrs. Muggenbuffin's house. The inspector estimates that currently there are 200,000 termites, but he can use a chemical solution that will decrease the termite population by 8% each hour. So since this is a percent decrease, we know this is a geometric pattern, not arithmetic. So if we're writing an equation, we need an initial value, which is given. Currently there are 200,000 termites, and we need a multiplier. So if it is a decrease of 8%, to find the multiplier, I need to subtract that percentage from 1, which leaves 92% for the multiplier. And then to the nth power. How many termites will be left 24 hours after the solution is applied? So using our equation, 24 hours is the value we're going to plug in for n. And if we evaluate that, we can round, so 27,035.7, so we can round up to 27,036. How long will it take for the termite population to be essentially eliminated? So now we're finding what n is equal to when our population basically becomes less than 1, because once we have less than 1, we can assume that the termites have been eliminated. So this is a matter of guess and check to figure out what n could be equal to so that we have less than 1 termite. So it turns out after guess and check that this ends up being approximately 147 hours. And again, you'd have to guess and check to come up with that. There's no quick or fast way to do that. So to the 147 hours later, there's 0.95, so we're down to less than 1 termite. So essentially they've been eliminated. Alright, number 2 is also a percent problem. Mrs. Muggenbuffin sells hand-knitted hats and mittens on Etsy. She currently has an inventory of 28 hats, 79 mittens. She expects the hat sales will increase by 18%, mitten sales will decrease by 5%. So for the equations, we need one equation for hats, one equation for mittens. The hats, she currently has 28. The hats are going to increase by 8%. So when you have a percent increase, it's a geometric scenario, and we're adding 18% to 1, which gives us 1.18 as our multiplier. The mittens are starting at 79 pairs, decreasing by 5%, so we need to subtract 5% from 1 to get a multiplier of 0.95. Now, in order to keep her shop open, she must be ready to sell at least 100 hats and at least 50 pairs of mittens. 1 year from this month will she be able to keep the shop open. So 1 year from now would be 12 months. So checking the hats, she has about 204 hats after a year, so she's good on the hats since it's over 100. Now checking the mittens, $12 months later, so 79 times 0.95 to the 12th power, about 42, which is less than the 50 that she needs. So we'll say no, she can't keep her shop open.